The high-altitude war over Europe in 1943 had turned into a brutal test of machines as much as men. For the U.S. Army Air Forces, the Lockheed P-38 Lightning was supposed to be the long-range spearhead of daylight bombing raids. Twin engines, turbo superchargers, and heavy firepower gave it the look of invincibility. But beneath its sleek design lurked a problem that pilots whispered about with dread. When the Lightning plunged into a steep dive, control surfaces locked, the aircraft shuddered, and the stick froze solid. More than one pilot had watched the Earth race upward, helpless to pull out. The Germans knew this weakness. Luftwaffe veterans flying Messerschmitt Bf-109s and Focke-Wulfs FW-190s used a simple tactic. When outmatched, they rolled over and dove straight down. The P-38, fast but cursed with compressibility, could not follow. German pilots called it the American coffin dive, certain that no Lightning could recover at such speeds. Every time a P-38 leveled off early, every time an American wingman vanished in a gray cloud below, the Luftwaffe's confidence grew. American engineers understood what was at stake. The flaw wasn't just technical, it was strategic. If German fighters could always escape, the P-38 would never dominate the skies. Lockheed's design teams, pressed by the U.S. Army Air Forces, began hunting for a fix that didn't yet exist in any aviation handbook. Could a few ounces of aluminum save a multi-million-dollar war effort? This is where our story begins, not with a triumph, but with a weakness so dangerous that it nearly doomed one of America's most ambitious aircraft. A weakness the Germans had no idea was about to be erased overnight. Before we dive deeper, make sure to like and subscribe so you don't miss the rest of this incredible untold history. What followed would shock Luftwaffe pilots who had trusted physics itself to protect them. For once, German crews would find that their best escape maneuver had turned into a death trap, and it all hinged on a device no bigger than a dinner tray. To understand the P-38's peril, one must step into the invisible battlefield of airflow. At high altitudes, as speed increased past 400 miles per hour, air no longer behaved as engineers expected. Shockwaves formed across the wing surface, disrupting lift and freezing controls. Pilots described it as if an invisible hand held the yoke in place, no matter how desperately they pulled. This phenomenon, compressibility, was scarcely understood in the early 1940s. Textbooks offered little guidance, and wind tunnels of the era could not replicate the extremes of combat flight. For German fighters like the Messerschmitt Bf-109, lighter and designed for sharp dives, compressibility rarely became a factor. Their opponents could dive away, regain control at lower altitudes, and vanish. For American Lightning pilots, the consequences were stark. Training manuals warned against steep dives, but combat left no room for caution. Luftwaffe aces knew it, and the tactic became routine. When pressured, roll inverted and dive, confident the P-38 would hesitate. The results were devastating. Reports from the Mediterranean theater tell of pilots who blacked out during attempted recoveries, their aircraft striking the sea or hillsides at nearly supersonic speeds. Veteran Tony LeVier, later Lockheed's chief test pilot, nearly perished himself during a dive test, regaining consciousness only moments before impact. His harrowing survival convinced Lockheed that solving compressibility was not optional, it was urgent. American engineers dissected the problem with the same intensity used to crack enemy codes. Lockheed's aerodynamicists, led by Hall Hibbard and aided by the National Advisory Committee for Aeronautics, NACA, searched for ways to break airflow loose from the wings before it locked the controls. The solution was elusive. Adding weight or altering the wing could cripple performance. Time was slipping away as losses mounted. What made the quest even more desperate was German ignorance. Luftwaffe pilots did not know that compressibility was an Achilles' heel. They only saw the Lightning shy away in dives. To them, it was proof that American engineering was flawed. They could not have guessed that engineers in Burbank, California, were sketching ideas that would soon overturn the laws of survival in aerial combat. The fix would not be a new engine, nor a radical redesign. Instead, it would come from an idea so deceptively simple that few believed it could work at all. By late 1943, Lockheed's engineers faced mounting pressure from both Washington and the front lines. Letters from combat units pleaded for answers. The Lightning is superb, but in a dive, it kills our boys. For Clarence Kelly Johnson and his team, the challenge was not designing a new aircraft, but correcting one that was already flying thousands of miles from California. A conventional redesign was impossible. The Army Air Forces needed a retrofit, something that could be attached quickly to every Lightning in the field, without grounding squadrons for months. The idea emerged from wind tunnel experiments at NACA's Langley Laboratory. Researchers proposed that small surfaces placed under each wing could disrupt shockwave formation and restore elevator control. These would not be wings, nor air brakes, but specialized panels, dive recovery flaps. The concept was radical. Most believed only brute strength or entirely new wing shapes could counter compressibility. Could a lightweight aluminum plate, activated by an electric motor, truly tame the deadliest aerodynamic demon of the jet age's dawn? Lockheed took the gamble. Engineers sketched designs where the flaps, mounted just outboard of the engine nacelles, would extend automatically when pilots reached critical speeds. Installation was simple: bolts, wiring, and switches added in hours. But simplicity belied the risk. If the flaps malfunctioned, they could destabilize the entire aircraft, causing uncontrollable spins. Testing would require men willing to flirt with death in controlled dives, again and again. The program's urgency was underlined by cost. Washington allocated $2.8 million, a vast sum in 1943, yet small compared to the losses of trained pilots and aircraft. The gamble was not financial, but human. The fate of hundreds of crews rested on whether engineers had correctly interpreted data from charts and models that barely scratched the surface of high-speed aerodynamics. What made the plan remarkable was its secrecy. German intelligence, always eager to probe Allied innovations, remained oblivious. In Luftwaffe briefings, pilots still received the same advice: dive to escape the Lightning, and you will live. None of them imagined that American engineers were weeks away from rewriting that rule forever. The next step would fall to test pilots, men who would push the P-38 into near-suicidal dives, trusting new flaps bolted beneath the wings. The first prototypes with dive recovery flaps were rolled out at Muroc Army Airfield in early 1944. Here, in the desolate California desert, the fate of the Lightning would be decided. The man chosen to lead the trials was Tony LeVier, Lockheed's fearless chief test pilot. LeVier was already a legend within the company, known for his steady nerves and iron will. He had survived one near-fatal compressibility dive months earlier, waking in the cockpit seconds before impact. Now, he would willingly plunge again, this time with experimental hardware that had never been proven in combat conditions. The procedure was brutally simple. LeVier climbed to 30,000 feet, leveled off, and nosed the Lightning downward. Speed built rapidly, 350, 400, 450 miles per hour. The controls began to stiffen as they always had. At 500, the stick froze completely. LeVier's survival depended on a single switch. He flipped it. Beneath the wings, two modest flaps dropped into the rushing airstream. Instantly, the Lightning's nose responded. The elevators came alive. The aircraft trembled, but obeyed. LeVier pulled out cleanly, leveling at 10,000 feet with breathless ground crews watching below. Test after test confirmed it. With the flaps deployed, the P-38 could dive as fast as gravity would allow, and still recover. Engineers had transformed the Lightning's most dangerous flaw into a new weapon. LeVier himself later said, "I knew right then we had it licked. This was the breakthrough we needed." The program accelerated. Dozens of aircraft were fitted with the new system, and additional pilots joined the trials. Some dives reached speeds approaching Mach 0.7, regions of flight once considered suicide. Each time, the flaps worked. Lockheed's gamble had paid off. In secrecy, preparations began to ship retrofit kits overseas. Crates marked only with serial numbers left California by train and ship, bound for air depots in England and Italy. Crews at forward bases would soon receive orders to install the mysterious new equipment. The modification required less than a day's work per aircraft. Soon, entire squadrons of Lightnings would be capable of diving with impunity. Across the Atlantic, German pilots still trusted their escape tactic. They had no idea the trap was already being set above them. By the summer of 1944, the modified P-38 Lightnings began arriving at bases in England and Italy. For ground crews, the new dive recovery flaps seemed almost trivial: 2 hinged plates and some wiring. Yet the pilots who had lost friends in failed dives treated the change with reverence. Squadron diaries from the 55th Fighter Group noted the first modified Lightnings in July, with one pilot writing, "If this works, we may finally chase the Hun into the ground." The timing was critical. The Allies had just landed in Normandy, and the Luftwaffe was throwing its remaining strength into desperate counterattacks. German fighters, though fewer in number, retained an edge in certain maneuvers. For months, American crews had accepted that Messerschmitts and Focke-Wulfs could always break contact by diving. It was a bitter pill. Even when victory seemed within reach, the enemy could slip away. Now, with the retrofit complete, Lightning pilots prepared to turn the tables. Training flights tested the flaps over English countryside, pilots deliberately pushing into near compressibility dives, recovering cleanly and pulling level with exhilaration. Some could hardly believe it. The same maneuver that had once claimed their comrades was now safe, almost routine. The Lightning had become a predator with a new weapon, invisible to its prey. Meanwhile, German intelligence officers scoured reports of American technology, but saw nothing unusual. Their focus remained on the P-51 Mustang, whose range had shifted the balance of the strategic bombing campaign. The Lightning, though respected, was considered flawed. Luftwaffe tactical manuals still encouraged deep dives as a survival tool against American pursuit. No warning reached frontline pilots that the rules had changed. In briefing rooms across Britain, U.S. commanders quietly adjusted tactics. Pursuit maneuvers once forbidden were now ordered. Pilots were encouraged to stay on the tail of diving Germans, to follow them into the depths of the sky. Soon, the Luftwaffe would discover in the most brutal way possible that their trusted escape route had become a death sentence. The stage was set for a confrontation that would shatter German confidence. The first combat tests of the dive recovery flaps were about to unfold in the deadly skies above France. The chance to prove the Lightning's new edge came in late July 1944, when the 20th Fighter Group was tasked with escorting B-17 formations over central France. The Luftwaffe scrambled to intercept, dispatching Bf-109s from Jagdgeschwader 27. Above the contrail-lined skies, the familiar duel resumed. Germans darted into bomber formations, then broke for home once American escorts engaged. But this time, the ending was different. Captain Jack Ilfrey, a seasoned P-38 ace, spotted 2 Messerschmitts rolling into steep dives. Instinct told him to level off. Months of training had conditioned Lightning pilots to avoid compressibility traps. But Ilfrey's aircraft carried the new flaps. Heart pounding, he pressed on. The Germans, assuming safety, relaxed as their altimeters unwound. Then came the shock. The P-38 stayed glued to their tails, the gap closing foot by foot. At 20,000 feet, Ilfrey triggered his guns. One Bf-109 erupted in flame, the other sheared away too late. Radio chatter crackled with disbelief. "They can't get away anymore!" Pilots who had once cursed the Lightning's limitations now exulted in its transformation. In squadron reports filed afterward, commanders noted multiple kills achieved in dives where Germans expected immunity. For the Luftwaffe, it was the first inkling that something fundamental had changed. What made the victories so crushing was psychological. For years, German pilots had banked on physics itself as their ally. Now, mid-dive, they felt hunted in what had always been their sanctuary. Survivors described the shock of seeing P-38 still looming behind them, refusing to vanish in the thinning air. Luftwaffe intelligence officers, puzzled, sought explanations. Some suggested that the Americans had secretly lightened their aircraft or installed stronger elevators. Others dismissed the accounts as exaggerations by shaken crews. But frontline pilots knew better. The Lightning had shed its weakness. The trick of the dive, their once reliable lifeline, had been stolen from them. For American units, confidence soared. Escort missions, once fraught with frustration, now offered the chance to finish fights on their own terms. No longer did enemy fighters escape by simply pointing their noses earthward. The battlefield dynamic had shifted, and the Luftwaffe's bag of tricks was growing empty. As word spread among Allied squadrons, tactical doctrine evolved to fully exploit the P-38's newfound capability. Squadron leaders adjusted formation strategies, allowing Lightnings to pursue high-speed dives without breaking cohesion. Pilots who had once hesitated at 400 miles per hour now pressed aggressively, knowing the dive recovery flaps could withstand extreme forces. Combat over Normandy became a laboratory for experimentation, each engagement revealing new possibilities for exploiting the Lightning's advantages. In one notable encounter, Lieutenant Robert Sutherland's flight intercepted a mixed formation of FW-190s over the hedgerows near Caen. The German fighters initiated high dives, confident in their ability to escape. Sutherland's wingmen followed the descent, maintaining tight formation and cross-cover. As they approached the bottom of the dive, Sutherland pulled back gently on the stick, the recovery flaps absorbing the extreme airflow. German pilots, expecting the usual American hesitancy, were stunned to find Lightnings still on their tails. Within minutes, 3 FW-190s were destroyed, one crashed into the countryside, and the remaining fighters scattered, demoralized. The psychological impact of these encounters was profound. Luftwaffe units that had once relied on vertical escape maneuvers now found their options dramatically reduced. Reports from German frontline squadrons described pilots panicking mid-dive, shaking off coordination, and abandoning formation discipline. The dive recovery flaps had not only neutralized the mechanical weakness of the P-38, but also dismantled the Luftwaffe's trusted tactical habits. On the Allied side, intelligence officers compiled detailed analyses of each engagement, tracking German response patterns. They noticed a consistent trend. Once American pilots could follow dives safely, enemy losses increased disproportionately, even when outnumbered. Combat leaders adjusted flight rosters and attack vectors accordingly. The principle was clear. Controlling the vertical dimension of the battlefield now offered a decisive edge. Meanwhile, back at Lockheed, engineers monitored incoming reports with cautious pride. Field notes confirmed that the theoretical benefits observed in California's deserts had translated perfectly to European skies. The success of the dive recovery flaps validated months of research, testing, and secrecy. From dusty test airfields to chaotic dogfights above Normandy, the modification had shifted the balance, turning the P-38 from a vulnerable twin-engine fighter into a versatile predator capable of pursuing German aircraft without the limitations that had once threatened its pilots' lives. By August 1944, the Luftwaffe was beginning to grasp the scope of their predicament, though details remained murky. German intelligence intercepted reports of P-38 units following dives that were previously considered fatal traps. Field commanders, from the Ardennes to Normandy, were confronted with an uncomfortable truth. Their pilots' instincts, honed through years of combat, were suddenly unreliable. Experienced Jagdgeschwader officers expressed frustration in intercepted communications, noting that Messerschmitts and Focke-Wulfs were failing to escape from maneuvers that had always guaranteed survival. Colonel Erich Hohagen, a seasoned Bf 109 squadron leader, recorded in his personal diary that he had observed American Lightnings pursuing his formation through dives that once provided safety. He described his growing unease as pilots attempted evasive maneuvers only to find themselves still engaged. "It is as if the laws of physics themselves have turned against us," he wrote, underscoring the psychological toll of facing an opponent whose aircraft could now operate safely at speeds and altitudes that previously guaranteed enemy retreat. On the front lines, Luftwaffe pilots began experimenting with new escape strategies, diving at steeper angles or weaving aggressively, but these improvised tactics often proved insufficient against disciplined American formations. Engagement after engagement revealed a consistent pattern. P-38s could maintain pursuit, coordinating attacks across multiple aircraft, and German fighters were forced into reactionary roles. Victory, once assumed in vertical maneuvers, became precarious. Meanwhile, Allied mission debriefs highlighted how effective coordination could exploit these advantages. Pilots reported staying on enemy tails longer, calling for wingman support when diving into denser formations, and using dive recovery flaps to stabilize during sudden altitude changes. The lessons learned were quickly incorporated into tactical manuals. By September 1944, the combination of high-speed pursuit and enhanced aircraft safety had transformed the P-38 into a formidable instrument for air superiority missions. Even with these advantages, American commanders maintained strict secrecy about the flap's existence. Any mention was carefully removed from reports, ensuring that German intelligence remained unaware of the engineering breakthrough. For Luftwaffe pilots, the P-38's persistence in dives remained a mysterious, terrifying factor. Every encounter reinforced the perception of a superior machine and a more unpredictable enemy, eroding German morale while American airmen grew increasingly confident in their ability to dictate the terms of aerial combat. While pilots reaped the benefits of the dive recovery flaps in European skies, the story behind the modification unfolded thousands of miles away in the engineering offices and test hangars of Lockheed. In early 1944, Tony LeVier and a select group of test pilots had reported recurring compressibility issues at high-speed dives, where control surfaces would stiffen and the aircraft risked uncontrollable nosedives. Each incident was meticulously documented, forming the basis for a radical yet elegantly simple solution: electrically actuated aluminum flaps that could deploy during extreme dives, redirecting airflow and stabilizing the aircraft. The design team, led by Clarence Kelly Johnson, faced a daunting challenge. The flaps needed to be lightweight to preserve the P-38's performance while withstanding the forces generated at speeds exceeding 400 miles per hour. Rigorous testing at Burbank facilities involved repeated dives from over 25,000 feet, monitoring air pressure, control response, and structural stress. Engineers iterated tirelessly, fine-tuning flap geometry and motor reliability. Each adjustment brought incremental improvements, but the margin for error was razor-thin. A single mechanical failure in combat could mean disaster for an aircrew. Meanwhile, production teams coordinated the rollout across multiple Lockheed assembly lines. Secret orders dictated that modified aircraft be delivered to select units in Europe, without disclosing the change to either pilots or frontline intelligence officers. The operation required precise timing and coordination to integrate the new flaps while maintaining P-38 output to meet Allied operational demands. The stakes were high. These aircraft would soon face seasoned Luftwaffe pilots who had relied on exploiting the P-38's previous vulnerabilities for years. By summer 1944, the fruits of this engineering endeavor were clear. Field reports from pilots indicated remarkable improvements in dive stability and recovery, enabling previously impossible pursuit angles. Combat success in Normandy and subsequent operations validated the engineers' painstaking efforts. Each confirmed kill or successful escape reinforced the notion that innovation, no matter how subtle, could decisively influence battlefield outcomes. Lockheed's engineers, however, remained in the shadows. Their achievement, though pivotal, was never publicized during the war. Pilots flew missions unaware of the specific mechanisms stabilizing their aircraft, and German intelligence remained oblivious. The dive recovery flaps, simple in principle but revolutionary in practice, epitomized the often invisible technological advantage that allowed Allied forces to dominate skies while sowing confusion and fear among the Luftwaffe. As Allied forces pushed deeper into Germany, the P-38 Lightning's dive recovery flaps continued to redefine aerial engagement. By late 1944, Luftwaffe units had adapted as best they could, but the modification had already shifted the momentum irreversibly. American pilots could now exploit dives previously considered off-limits, forcing German fighters into defensive maneuvers with limited options. Each encounter further eroded confidence in traditional tactics, demonstrating how a subtle innovation could overturn decades of aerial doctrine. The flap's effectiveness extended beyond raw combat performance. Pilots reported fewer mechanical failures during aggressive maneuvers, enabling longer missions and more sustained air support for ground forces. Commanders in Europe recognized the broader strategic implications. The ability to pursue enemy aircraft at previously unattainable speeds allowed the Allies to maintain air superiority, protect bombers, and support advancing armies with unprecedented reliability. The modification, while simple in design, had cascading effects across operations, illustrating that engineering solutions often determine the outcome of large-scale conflicts. Post-war analyses confirmed the significance of the dive recovery flaps. Declassified reports revealed that the P-38's modification saved hundreds of pilots from fatal compressibility accidents, preserving experienced airmen who would contribute to both the final European campaigns and post-war military aviation developments. Engineers and historians alike credited the flaps as a prime example of practical innovation translating into decisive battlefield advantage. It also underscored the critical interplay between pilot skill, mechanical reliability, and forward-thinking design in shaping outcomes of high-stakes engagements. The story of the dive recovery flaps became a model for future aircraft design, influencing both military and civilian aviation. Lessons learned from stabilizing high-speed dives informed subsequent fighter aircraft, jet designs, and even aerobatic craft, demonstrating that attention to seemingly minor aerodynamic details could yield significant operational advantages. For pilots who had flown the Lightning, the flaps were more than a technical solution. They represented a tangible lifeline in the chaos of combat, enabling audacious maneuvers that reshaped air battle tactics. Ultimately, the P-38's dive recovery flaps exemplify how subtle engineering modifications can create outsized effects on warfare. By correcting a single vulnerability, American forces neutralized German tactical assumptions, protected skilled personnel, and ensured operational flexibility in critical theaters. The combination of ingenuity, secrecy, and practical application not only contributed to Allied air superiority, but also established a precedent. In war, small innovations often carry the greatest strategic weight, leaving a legacy that endures long after the battles have ended.